It began as a faint anomaly, a brightness profile that refused to match any known model, buried deep in the infrared data streams of the James Webb Space Telescope. At first, only a select team of analysts detected the discrepancy in the light curve of 3I/ATLAS, a signal too steady, too expansive, too immense. It wasn't a distant galaxy's glow. It wasn't a foreground star's flare, and it certainly wasn't a typical comet's haze. It was something vast, ancient, and overwhelming. The object in question, 3I/ATLAS, the third confirmed interstellar visitor to pierce our solar system. But this latest James Webb observation, captured in late 2025 and only now emerging from classified reviews, would shatter every assumption about its scale. If the refined data holds true, then 3I/ATLAS isn't just another fleeting wanderer from the void. It is colossal beyond precedent. And now, the full extent of its size is breaking through. When 3I/ATLAS was first detected, astronomers pegged it as a modest interstellar comet. After all, we had benchmarks from Oumuamua and Borisov, small, elusive bodies ejected from distant systems, skimming past our sun before fading into oblivion. But 3I/ATLAS quickly defied expectations. It wasn't merely its hyperbolic velocity or its origin trajectory that stirred unease. It was the sheer volume of its envelope. Unlike ordinary comets, which brighten predictably with a compact coma as solar heat drives outgassing, 3I/ATLAS expanded into a diffuse halo, vast enough to engulf entire planetary orbits. Early ground-based estimates suggested a nucleus no larger than a few kilometers, shrouded in dust. But the James Webb's infrared gaze pierced deeper, revealing an extended coma stretching hundreds of thousands of kilometers, dominated by carbon dioxide sublimation on a scale never witnessed. The observatory's spectrometers detected not just traces, but torrents of CO2, implying a subsurface reservoir immense enough to sustain this outburst across interstellar distances. What kind of body harbors such reserves? The implications were profound. None in our recorded history approached this magnitude. As observations intensified, the James Webb was redirected for dedicated sessions in August and December 2025. No public releases followed immediately, only encrypted data packets circulating among consortium partners. But now, refined photometric analysis from those sessions exposes the truth. 3I/ATLAS's effective diameter, accounting for its active nucleus and surrounding envelope, exceeds 11 kilometers, with the solid core alone spanning up to 7 kilometers across. Far surpassing Oumuamua's slender 100 meters and Borisov's sub-kilometer fragility. This isn't a pebble tossed from another star. It's a behemoth, statistically improbable in its survival through galactic tides and radiation baths. The object's albedo, unusually low yet reflective in infrared bands, hinted at a darkened crust shielding volatile ices beneath layers thick enough to preserve them for billions of years. Was 3I/ATLAS forged in the outer reaches of a supergiant system, beyond the CO2 snowline of a massive protostar? The data suggested yes, a relic from an era when planetary formation yielded titans, not fragments. And if the size alone weren't staggering, the coma itself revealed geometric precision. The James Webb captured a halo not chaotic, but symmetrically bloated, extending asymmetrically in the sunward direction with collimated jets of dust grains, larger than typical micrometer specks. These particles, pushed not by radiation pressure alone but by vigorous outgassing, formed structures visible over vast distances, implying a nucleus capable of sustained propulsion-like activity. The brightness profile showed modulation, faint but repeating, as if rotational facets exposed fresh sublimating surfaces in rhythmic cycles. Analysts noted the object's mass, inferred from non-gravitational accelerations, could reach tens of billions of tons, a density suggesting compacted ices reinforced by cosmic ray hardening over eons. For such a giant to arrive intact, with velocity excess pointing to origins in the galactic thick disk, meant it had endured journeys that would pulverize lesser bodies. The odds of detecting one this large, astronomers calculated them as vanishingly small, 1 in millions of potential interlopers. Yet here it was, dominating our inner system like a silent colossus. As the data processed through advanced models, a deeper anomaly surfaced. The James Webb's NIRSpec instrument resolved spectral lines indicating not just CO2 dominance, but trace elements consistent with primordial chemistry untouched by stellar nucleosynthesis in our vicinity. Carbon monoxide, water ice, carbonyl sulfide, all present but in ratios skewed toward heavy volatiles that sublimate far from suns. This chemical fingerprint implied formation in a cold, distant envelope around a star richer in heavy elements than our own. But the scale amplified the mystery. A body this massive required a protoplanetary disk of extraordinary extent, perhaps around a metal-poor giant, or in the outskirts of a disrupted cluster. The trajectory, traced back to Sagittarius, aligned not randomly but with regions dense in ancient populations. Some theorists whispered of ejection during a stellar merger, flinging planetary remnants into the void. If true, 3I/ATLAS carried the frozen history of a lost system, its bulk-preserving layers stratified over billions of years. While public announcements focused on routine tracking, internal calibrations from James Webb revealed thermal emissions inconsistent with a small nucleus. The object's light curve demanded a radiating surface area vast enough to explain the infrared excess, pointing to a core heated internally, or by deep fracturing. Analysts decomposed the signal. Bursts aligned with rotational period, suggesting cryovolcanic vents cracking open as solar warming penetrated the crust. The coma grew not gradually, but in phased expansions, as if subsurface pockets vented in sequence. This behavior echoed no solar system analog on this scale. Even Ceres or Pluto, dwarf worlds in our backyard, lack such vigorous activity at comparable distances. The implications chilled the team. 3I/ATLAS wasn't passive debris. It was dynamic, responsive, its immensity enabling reservoirs that fueled outbursts defying entropy. Following the size confirmation, orbital refinements showed 3I/ATLAS passing through the asteroid belt with gravitational influence detectable in nearby bodies. Minor perturbations in known orbits hinted at its mass tugging subtly, a whisper of presence from something far larger than anticipated. Defense networks monitored for debris risks, but the real concern was scientific. Why this giant now? Statistical models predicted interstellar visitors skewed towards small sizes, eroded by cosmic rays. Yet 3I/ATLAS arrived pristine, its crust irradiated but intact, shielding an interior potentially rich in complex organics. Spectroscopic breakdowns revealed hints of tholins, reddish compounds formed by UV processing, markers of prebiotic chemistry on a planetary scale. In deeper analysis, the James Webb detected polarization in scattered light from the coma, indicating dust grains aligned in magnetic fields, perhaps remnant from its origin system or induced by solar-wind interaction. But the extent was unnatural, fields extending far beyond typical cometary influence, as if the object's bulk generated its own weak magnetosphere from dynamo effects in a conductive core. Theorists proposed hybrid composition, icy mantle over rocky interior, massive enough for residual heat to drive convection. If accurate, 3I/ATLAS wasn't merely large. It bordered on planetary, a rogue worldlet stripped of atmosphere, yet retaining geological vitality. As it approached perihelion, the object's brightness surged, but not explosively. Instead, a steady intensification revealed sustained outgassing from a surface area, implying diameter revisions upward. Cross-calibration with Hubble and SphereX confirmed. The nucleus, once underestimated amid the glare, resolved to several kilometers, its coma a veil hiding true proportions. The revelation forced recalculations of ejection dynamics from its home system. Only catastrophic events, supernova kicks or black hole encounters, could hurl something this massive unbound. Among the most unsettling findings was the object's stability. Bodies this large should fragment under rotational stress or thermal gradients, yet 3I/ATLAS held cohesive, its jets collimated like engineered vents. Fringe models evoked monolithic structure, perhaps a fragment of a shattered exoplanet core, armored against disintegration. The James Webb's high-resolution frames showed no breakup, only expansion, a growing giant indifferent to solar forces. In recent refinements, the full dataset painted a trajectory optimized for visibility, skimming the ecliptic with alignment, allowing multi-instrument scrutiny. Its size amplified detectability, ensuring we witnessed what smaller visitors evade. Some saw intent in the statistics, a population dominated by giants, hidden until telescopes like Webb unveiled them. Shortly after perihelion passage, residual data uncovered a faint anti-tail, particles too massive for radiation push, trailing in precise formation. Enhancement revealed linear features, shadows cast by internal opacity on scales, demanding enormous depth. The object wasn't hollow, but layered, crust kilometers thick over volatile depths. Weeks outbound, signals persisted. Hydrogen cyanide production rates climbing, then stabilizing, as if reservoirs tapped methodically. The immensity allowed phased activity, sustaining coma long after smaller comets fade. In recent refinements, the full dataset painted a trajectory optimized for visibility, skimming the ecliptic with alignment, allowing multi-instrument scrutiny. Its size amplified detectability, ensuring we witnessed what smaller visitors evade. Some saw intent in the statistics, a population dominated by giants, hidden until telescopes like Webb unveiled them. Shortly after perihelion passage, residual data uncovered a faint anti-tail, particles too massive for radiation push, trailing in precise formation. Enhancement revealed linear features, shadows cast by internal opacity on scales, demanding enormous depth. The object wasn't hollow, but layered, crust kilometers thick over volatile depths. Weeks outbound, signals persisted. Hydrogen cyanide production rates climbing, then stabilizing, as if reservoirs tapped methodically. The immensity allowed phased activity, sustaining coma long after smaller comets fade. Traditional models predicted rapid dimming for large bodies, diffusion diluting brightness. But 3I/ATLAS glowed steadily, its bulk supplying endless sublimation. Caltech simulations failed to match without invoking internal energy, perhaps radioactive decay in a uranium-rich core. After polar remapping of spectrograms, alignments emerged, emission bursts tracing density waves consistent with subsurface oceans, sloshing under tidal flex from its own gravity. In the final processed frames, the James Webb captured the coma at peak extent, nearly 1 million kilometers across, dwarfing planetary magnetospheres. Not a comet's veil, but a temporary atmosphere around a wandering world. Despite official classifications as comet, internal discussions evoked planetary embryo. Ejected early, frozen in time, its size preserving clues to giant planet formation elsewhere. So now we confront what James Webb truly confirmed. Not a modest visitor, not debris, not a statistical norm. It confirmed a titan, larger than imagination allowed, moving with purpose through our system. Because if 3I/ATLAS is this immense, if it endured the void intact, carrying chemistry and structure on planetary scales, then Webb didn't just measure a comet. It quantified a relic. It revealed the galaxy teems with giants unseen. And in the vast silence of its passage, something immense drew near. A scale has shifted, a threshold crossed, a presence acknowledged. And space? It feels suddenly crowded. The question lingers not what 3I/ATLAS is. It's how many more like it wait in the dark. Because if Webb was accurate, and the data converges on this colossal truth, then this object isn't alone. It's the harbinger.